Chapter 3, Section 3, Central Boiling Plants, Optimizing Central Plant Efficiency. 1334, Optimizing Combustion Efficiency. Within the cost of the field continuously increasing the need to operate central boiler plants efficiently becomes important at all times. Procedures optimizing operation efficiency is discussed in the section. Operators shall review the elementary combustion principles and principles steam and hot water generation found in Chapter 1. Optimize boiler efficiency with the combustion efficiency most first to optimize. We have seen in paragraph 111, 14, table 111, tables 14, 15, 16, 17, 18, the combustion efficiency with the function type of the fuel, flow gas, the temperature amount of the excess for the fuel gas for the given fuel. The operator must take action to optimize the combustion efficiency by maintaining a low flue gas temperature excess the air level as possible. Soup blowing, cleaning of the reduced flue gas for the temperature on all boilers equipped with the soup boiler. Should be the operator with the needed to maintain the clean heat of the trans surface. Once a shift is recommended, internal oil cooling is being fired, but through the experience may be dictated at different intervals with a particular unit. Note the flue gas temperature before the suiting of the blowing with reducing the temperature 35 degrees, 45 degrees corresponding to the efficiency improvement of 1%. Reference to table 1.5 and through 1.8. The specific improvement of the actual temperature excess air levels which are operating for the 4 fire tubes not equipped with soup blowers. Record flue gas temperatures normal. The higher in the rate boiler should be kept with the flue gas temperature exceeding the clean boiler flue gas and maybe more than 70% of the degrees, 70 degrees Fahrenheit. The boiler should be taken once over the clean. The fire tube boiler should be as minimum clean during the quarterly inspection. Waterside cleaning. Maintaining the water side of the boiler is equally important. Maintaining the fire side of the scale of the water side reduces the heat the transfer suit does, thereby increasing the fluid of the gas temperature, reducing the efficiency, maintain proper the water treatment. The program described in Chapter 4, quarterly inspection, mechanically inspection, cleaning by required chemical cleaning may be required. Occasionally, the operator should know that the flue gas of the boiler is normal firing rate, excessive air level of the gas firing the water side of the clean. Any major change in the temperature of the firing conditions indicate the problem. Typical dirt gases and water side transfer surfaces. Setting leaks. Any leak with the boiler system increase the excess air level to reduce the efficiency of any air drawn in the boiler throughout the leak of the furnace setting and cause casing flues and the mess be heated with the room temperature, the fluid gas temperature heat, but the could otherwise transfer the steam. Normal maintenance should be greatly reduced. Normal side of the leaks. Reference to paragraph 511. The operator should ensure all doors of the post with the opening with the surface furnaces are closed with the tightly furnace draft should be maintained with a slightly negative level of negative 300s or negative 10 100s. Oh, wow. The practice of helping minimize the air leaks with the draft increase with the soup blowing, taking care of the return of the normal level of the soup blowing complete. Using the continuous oxygen to analyze the transverse as the stack flue and the contains sometimes helps to locate air leak and should showing a higher normal excess air level. D. Baffles. To obtain the maximum heat absorption, baffles are used to help direct the hot gas over the tube. The arrangement vary widely depending on the tube of the arrangement. The baffles restrict the flow of the gas effects of the draft flow effect required for the boiler. Defective baffles allow the gas to short a circuit. They do not pass over the entire heating of the surface. The leaking baffles become as a result of the high outlet gas temperature increased efficiency. Leaking baffles usually distinguish them from heat and the transfer surface. Their effective draft leaves. The leaking baffles decrease the gas, while the fouled surface increase the draft loss. Always investigate, report change in the flue gas temperature of the and draft losses. Your fuel air ratio optimization. Reference to paragraph 328 of the combustion control fuels air ratio adjustment. Knowing the process of excessive air limits for each firing rate. When the proper levels are known, corrective action can be taken if their fuel air rate is out of adjustment. So corrective action as return of the oil header pressure for the temperature for the operating point with adjusting the stroke feed with the returning of the furnace draft to the operating point. The basic fuel air ratio may be taken by the operator. In additional corrective action is required. Note that this is the boiler log informing the responsible personnel with the optimum fuel air ratio, winter load with the probably not optional with the summer load. Determine the optimum ratio over the full load range for the boiler. Post of the chart where it is readily access the operator with the table 3.1 give the recommendation of oxygen, carbon dioxide, except for the air levels, fuel load, full load, 50% load, 25% load, typical equipment. All boilers will be not able to operate with these levels, but this level of performance is possible. Modern correctly adjusting equipment plant modifications to reach the levels may be economically justified based on the fuel saving resulting from improved combustion efficiency. All right, table 3.1 shows the flue gas handling at 25, 50%, and 100% load. Natural gas, oil number 2, oil number 6, oil and stroker Your load percents for the natural gas number 2, number 6, and number oil load percentage, oxidized oxygen percent, carbon dioxide percent, and excess air percent. 335. Optimizing boiler efficiency. Boiler efficiency account for the energy loss and can indicate with the combustion efficiency of the plus for the energy loss associated with the heat rating with the boiler casing when it has been removed with the blowdown. Heat loss due to the combustion. Boiler efficiency is affected with the stability of the combustion controls. Boiler efficiency is always less than the combustion efficiency. Reduce radiation loss. Inspect, maintain, and improve the boiler flue. Pipe installation, improve the insulation often available. The economically justified radiation loss can be minimized by proper selection of operating standby boilers. The temperature of the standby boilers are maintained. Some of the plants operating with a non-critical load standby boiler are not be maintained in hot condition. Check close the inlet and outlet damper to the standby boiler. This will help to minimize the natural draft airflow, which will cool the boiler. B. Reduce the blowdown loss. The blowdown is necessary to control the steam boiler water quality, minimize the scale of information. Reduce scale of information helps to maintain combustion efficiency near clean boiler levels. Reduce the size of the maintenance blowdown is a form of the preventive maintenance that should be carefully controlled. Reference paragraph 4.8. The closed blowdown recommended with the steam boiler because the blowdown is a heat exchange, but can be recovered the heat below the blowdown water. The reheating will make up water. Automatic control of the continuous blowdown is always recommended to improve the accuracy of the blowdown procedure. Help minimize the losses. C. Reduce unburned carbon loss. The unburned carbon loss for the oil gas fired boilers are always negligible because of the fuel burn easily accessible for the air level of the smoke easily controlled. Unburned carbon losses for the stroker fire boilers, however, the ending can be significant. Strokers should be carefully maintained and operated to minimize unburned carbon loss. There is re-injection system, whether important, but the spreader stroke system, which must be maintained in good operative condition. Over fire air, also very important in any stroker system to obtain the proper mixing of the air combustion gas. Reference option procedure 317. D. Stabilizing combustion control. The combustion controls must accurately establish the correct fuel-air ratio, optimize the combustion fuel efficiency. Combustion controls are designated to regulate fuel-air flow with the satisfied loss of demand, establish correct fuel-air ratio, minimize time spent, efficiency, fire condition of the combustion controls are stabilized, making the proper adjustment of the proper proportional band integral rating settings, and best respond to local conditions with common best settings with the winter load conditions. That's best for summer conditions. Assistance for the control manufacturer may be required to determine the best settings. The settings should be changed only by trained authorized personnel. 336. Optimizing central boiler plant efficiency. Overall plant efficiency is always less than the boiler efficiency. Reference to Figure 113. Initial discussion of boiler plant efficiency after the individual boiler efficiency is optimized. The consideration must be given to the proper boiler section, the aerator control using steam-driven auxiliary build energy conservation modification, additional plant equipment. Boiler section. The best use of available boilers necessary to optimize plant efficiency. A curve of the efficiency various load should be developed for each of the boiler based upon the data obtained within the fuel-air ratio were developed. Figure 3.6 illustrates with such a curve with the information possible to select the boiler for the group of the boilers best be suited to operate the given load. The steam demand of 330,000 pph or operate the boilers number 1 and 2 would be economically efficient. The particular boiler is good only with a very small range, and it may be best to base load of the boiler to the range allow the other boilers to handle the load swing. 2 boilers operating the partial load may be efficient for 1 boiler operating near the design capacity. Standing operating procedure should be developed. Establishing the boiler should operate with a given load. B. The deaerator control. Reference paragraph 4, 6, and 416C. The deaerator comes with a significant amount of steam. The heat in the deaerator feeds water. Some of the steam is vented with the atmosphere. The loss of the amount of the vented from the 1/10% with the 1% of the plant loading is dependent upon both of the original design deaerator, the vent condenser, and the proper operation. With the poor operation of the design, 5% or more of the plant load can be vented with the deaerator. The operational load does not resolve excessive venting of equipment, and modification replacement should be considered. See, steam-driven auxiliary. Steam-driven fans pump that may be usually provided with the plant. They can be operated with electrical failure. Must be taken out with utilizing such drivers because they have significant plant efficiency. The efficiency of the non-condensing steam turbine is only about 20% suitable. Use for the external steam must be therefore need to be developed in steam turbines as used effectively operating steam drives only when using low-pressure exhaust steam is available. 3.6 shows the boiler efficiency versus the load. Boiler efficiency percent of 0 to 90 And your pounds of steam per hour by 1,000. Boiler number 1 is 300 horsepower, 4 bypass fire tube. And boiler number 2 is a 30,000 pph water tube. Number 3 is 40,000 pph water tube. Plant building conservation. Overall, the plant efficiency can be improved with minimizing the use of the plant generated with energy building heat. Use of the water, waste heat with the condensate, the return blowdown water, the boiler radiation, whatever the possible, insulating the building, maintaining building steam trap to repair all water of the steam lake immediately, provide vent condensers, the condensating well, deaerators, heaters, use the minimum steam pressure, practical heating exchange, reference paragraph 12B1, energy loss, equipment modification additions. Existing equipment does not operate with efficiency should be modified to replace it. Economically justified economizer air heaters should be considered with a boiler that is normally operated with a gas temperature above 500 degrees Fahrenheit. If this boiler operates for a significant period of the year, 5% of the improvement of the boiler efficiency is common can often be economically justified. The addition of such equipment, improvements of external water treatment may be justified in significant reductions, and blowdown quantities can be realized. The additional blowdown heat recovery system should be considered. The use of vent condensers condensate the heat recovery system, improve steam traps, upgraded boiler combustion controls should also be considered economical. Such modifications and be careful to be reviewed. It will be often found that potential energy saving will also be pay back the capital investment required. Alright, F. Distribution system effective plant efficiency. With less water with the return of the central plant was supplied with the form of steam with the hot water plant efficiency reduced. Makeup of the water must be heated with the supplied temperature usually 60 degrees Fahrenheit, while condensation return water needs only to be heated already elevated temperature of 150 to 180 degrees Fahrenheit. It's important to monitor and supply return flows as well as in wake up to determine the excessive loss occur. Know that the temperature compensation is required to accurate flow comparison. If the loss is determined except for the other problems developed, an appropriate personnel should be alerted to the repair of the distribution system can be made. Distribution system losses should not exceed 5 to 10% supplied fuel and steam system and 1% hot water system. Chapter 4: Water treatment for boiler plants.